All right, so today we're going to be doing one-step inequalities, lecture 24. So when we do inequalities, we're going to do them like equations, but they're going to be done a little bit differently. When you solved equations, you always had an equal sign. So for example, x plus 8 equals 10. For equations, we use an equal sign. But for inequalities, we're not going to be using an equal sign. So the first symbol we're going to look at is the less than symbol. Here, this symbol is a less than symbol, and we say that x is less than 8. So that means x has to be a number that's smaller than 8 or less than 8. We also have greater than signs. This is a greater than symbol. And for this one, we say that x is greater than 8. So x has to be a number that's bigger than 8, like 9 or 10. And then we have two more that I want to look at. There is the less than or equal to. So less than or equal to. This one says that x could be less than 8, or it could actually be equal to 8. And then the last one we're going to look at is greater than or equal to. This one says x is greater than or equal to 8. So that means that x has to be a number that's bigger than 8 or equal to 8. So for the less than symbol, we're always going to have open circles. And same way for the greater than symbol. We're also going to have open circles when we graph. When we have less than, that means we're going to shade to the left. So we're going to be shading to the left. But when we have a greater than symbol, we're going to be shading the opposite direction. We're going to be shading to the right. For the less than or equal to symbol, we're not going to have an open circle. Since we have this equal to sign under it, that means we're going to have a closed circle or a closed dot. That's what I'm going to write, closed dot. And since it is less than, that also means that we're shading to the left, just like we would if it was a less than symbol. And then the last one is greater than or equal to. Since we have that equal to symbol at the bottom, we're also going to have a closed dot, just like the last one. And for this one, since it's a greater than symbol, we're going to be shading to the right, just like we would for the greater than symbol over here. So all of these rules at the bottom pertain to how we're going to graph on a number line. So for each question we do today, we're going to solve it first. We're going to solve it first. We're going to write our solution set, just like we will equation. And then we're going to graph the solution on a number line. So we're going to graph on a number line. So those are doing for each question. Look at the problem. Okay, what's going on here? Okay, is it working now? Okay. Let's try the first one. X plus 2 is less than. All right, so what I need to do is I need to get X by itself. So to get X by itself on the left side, I need to get rid of this plus 2, which means I'm going to subtract 2. So I'm always doing the opposite of what I see. So now the 2's cancel out, and I'm just left with an X, a less than symbol, and then on the right side, I have 4 minus 2, which is going to give me 2. So now I know that X has to be less than 2. My solution set, the all, and then I'm the all X, and I use the brackets. So that's going to be how I write my solution set. Here, I'm going to graph it on a number line. So I draw my line, I put arrows at both ends, and I'm going to take my answer as a number and put it in the middle. And all the numbers that are less than 2 are going to go on the left side. So numbers like positive 1, 0, negative 1, that go on this side. But then numbers that are greater than 2, like 3, 4, and 5, they're all going to go on the right side. So now to graph this, since I have a less than symbol, I'm going to need an open circle. I'm going to put an open circle. And then since the less than symbol, I need to shade, so we're going to shade to the left. Shade to the left. Shade. And the way I do that is I kind of just draw to the left and Okay. This again. Okay. That's how you do an inequality. We solve it first, do the solution set over here, and then we graph it on a number line. Let's try a second. X minus 3 is greater than or equal to 5. So for this one, I need to get the x by itself. Minus 3. So to get rid of the minus 3, I need to add 3. We're going to add 3. Both sides. Like this. And then the minus 3 and the plus 3 are going to cancel out on this side. And then 5 plus 3 is going to give you 8. So greater than or equal to 8. My solution set is going to know all the real numbers x, such that x is greater than or equal to 8. So that's my solution set. And I'm going to graph it on the number line down here. I'm going to put my 8 in the middle. All the numbers that are lower than 8 are going to go on the left side. So numbers like 7, 6, but numbers that are bigger like 9 and 10 are going to go on the right. So since I have x that's greater than or equal to 8, I'm going to need a closed dot. So I'm going to put a closed dot on 8. Looks like that. An open circle, but I fill it in. So now it's a closed dot. And since it's greater than or equal to 8, that means that I'm going to shade to the right. So that greater than symbol is going to tell me to shade to the right. And that's my answer. Another way you can tell this inequality arrow is actually pointing to the right. So you could also think that way, as shading to the right. Okay, let's try number 3. X divided by 2 is less than or equal to 7. So for this one, I need to get x by itself on the left side, which means I've got to get rid of this 2 at the bottom. I can do that by multiplying both sides by 2. So I multiply the left side by 2, and I also multiply the right side by 2. So we're going to be multiplying this 7 by 2. What that does is it's going to cancel out the 2 in the numerator and the denominator. So I'm only left with x. I bring down my less than or equal to symbol right here. And then 2 times 7 is going to give me 14. So x has to be less than or equal to 14. I write my solution set. All the real numbers x, such that x is less than or equal to 14. And then my number line is going to be at the bottom. I'm going to put 14 in the middle. 15 and 16 are going to go on the right side. And 13 and 12 are going to go on the left-hand side. Since it's a less than or equal to symbol, I'm going to need a closed dot on the 14. And then which way do I shade? Since it's a less than symbol and it's pointing to the left, that means I'm going to be shading to the left. So I'm going to shade to the left, just like that. And then I'm going to shade the left arrow. So what this means is I can choose 14 or any number that's less than 14 to be my answer. So any number that actually gets shaded is going to be part of my solution set. So numbers like 13 and 12 are going to be part of the solution set, but numbers that don't get shaded like 15 and 16, they do not belong to the solution set. Okay, the last one we're going to do is number 4. I have negative 2x is less than negative 6. So for this one, I need to get x by itself, but I need to get rid of the negative 2 that's in front of it. Now, since I'm multiplying by negative 2, I'm going to do the opposite to both sides. I'm going to divide both sides by the negative 2. So the negative 2's are going to cancel out, leaving me with just an x. On the right side, I have negative 6 divided by negative 2. That's going to give me a positive 3. And then since I'm dividing by a negative number, I need to flip the inequality symbol. So instead of becoming a less than, it's going to become a greater than. So whenever you multiply or divide by a negative number, you flip the inequality symbol. You flip the inequality. So instead of staying a less than, it's going to become a greater than symbol. So then my solution set is going to be all the real numbers x, such that x is greater than 3. Then I draw my number line. I'm going to put 3 in the middle, and then 2, and then 1, 4, and 5 go on the right. Since it's a greater than symbol now, I know that I'm going to have an open circle on 3. So I'm going to put my open circle on the 3. And then which way do I shade? Since it's pointing to the right, I'm going to shade to the right. Okay, so one word of caution before you start your classwork. Sometimes you'll see inequalities where the variable is on the right-hand side. If you have something like this, you would solve it as normal. So you could add 2 to both sides. Everything stays the same. 5 plus 2 is going to give you 7. And you have 7 is less than x. Well, since x is on the right-hand side, I can actually flip this around so that x can be on the left-hand side, but the inequality sign has to flip. One way you can think about it is the inequality sign is pointing at the 7. It's pointing at the 7 right here. So it has to point at the 7 when you flip it as well. So the less than is going to become a greater than. So just a word of caution if x is on the right-hand side. You won't see that often, but it does come up. So in this case, when you graph it, you're going to be shading to the right instead of shading to the left. So you could have 7, 6, and 8. You're going to have that open circle on 7 because it's a greater than symbol. But because you flip the inequality sign, it's now pointing to the right. So I need all the numbers that are greater than 7 to be shaded. So that's what your solution is going to look like when you graph it. All right, that's all I got today. Any questions, you can put them in the chat box. The 2 assignments that are going to be due on Sunday are going to be the one-step inequalities, which we're doing today. And then on Wednesday, we're going to do the multi-step inequalities, which are a little bit more difficult since you have more steps, but it'll be the same ideas that we talked about today.